So in class today we discussed multiplicity and writing polynomials from a graph. So multiplicity of a zero, okay, just tells you how many times that factor appears in the factored form of the polynomial. Okay, and so we want to write a polynomial function for this graph, and we want to use the least degree possible. Okay, so just as a refresher, if we look at this graph before we do anything else, and note the end behavior. So this tells me that I know it is going to be, since the end behavior is in opposite direction, this is going to be an odd degree. And if we count the turning points, okay, if we look at the turning points here, we have 1, 2, 3, 4, okay, so 4 turning points. And so this tells me, okay, that we have at least a 5th degree polynomial, at least 5th degree. Okay, so that's just using our prior knowledge to kind of give us an idea of what kind of polynomial we will end up with. Okay, so the other thing we've talked about previously is the fact that if R is, so some real number R is an x-intercept, okay, then x minus R is a factor. So if I look at my x-intercepts, okay, I have one here at -3. I have one here at 0. And I have one here at +3. Okay, so my x-intercepts are, so my x-intercepts, or zeros, okay, so x-intercepts and zeros, so x-intercepts / zeros are -3, 0, and 3. So that means I have factors. Okay, so if -3 is a 0, then x minus -3 or x plus 3 is a factor. If 0 is a 0, then x minus 0 or just x must be a factor. And if 3 is a 0, then x minus 3 must be a factor. So I've identified all the factors that are going to make up this polynomial. Okay. Now we need to consider what we talked about today, the multiplicity. Okay, and multiplicity also tells us how things behave, how these things behave around the x-intercepts. Okay, so we had a few examples. So if we had a multiplicity, so if we had a multiplicity of 1, okay, that means that let's see, if we draw ourselves, if this is our x-axis, okay, multiplicity of 1 meant that the graph just crossed the x-axis linearly. Okay, a multiplicity of 2, meaning the factor occurred 2 times, means that at our x-intercept, it just touches the x-axis. Okay, And we also looked at the multiplicity where it kind of went through the x-axis, but it kind of flattened out near the x-axis, and we said that this had a multiplicity of 3. And you can find all these descriptions in the Desmos activity that we did today as well. Okay, so if it crosses like a line, we know it has a multiplicity of 1, meaning it just occurs once. If it just touches the x-axis, okay, we know that it's even, okay, and in this case, if it looks like a parabola where it touches the x-axis, it means it's going to be a multiplicity of 2. And if it sort of comes up and goes along the x-axis before crossing it, okay, we're going to say that's a multiplicity of 3. So even multiplicities touch the x-axis, okay, and odd multiplicities cross the x-axis. So looking at that at -3, okay, if I look at this, this touches the x-axis and goes back up. So this has a multiplicity of 2. Okay, and then this at 0, it crosses linearly. Okay, so our x has a multiplicity of 1, and at +3, again, it just touches the x-axis. Okay, and we're going to say that's a multiplicity of 2. And now we can start putting together pieces. Notice that the sum, okay, the sum of all of our multiplicities, okay, is the degree of the polynomial. Okay, so sum of multiplicities is the degree. Okay, and so we have a degree 5. Okay, which matches with what we said, that it had to be odd and it was going to be at least a 5th degree polynomial. Okay, so all these things have to sort of make sense. And so now we can put this together. So I can say that f of x could be, and we're always going to have an a here, okay, giving us room to sort of adjust this polynomial. But I know it has a factor of x. It has a factor of x plus 3, which has a multiplicity of 2, and it has a factor of x minus 3, which also has a multiplicity of 2. Okay. Now, I've got one more piece of information here. It goes through this point, 2, 50. Okay. So that means, okay, that my output is -50 when my input x is equal to 2. And so by substituting that in, okay, I can say -50 is equal to a, and everywhere I see an x, I'll plug in 2. And so now I can solve for a. Okay. And so I get -50 is equal to 2a, and this becomes 25, and this becomes just 1. Okay, and so I've got -50 is equal to 50a, and so a must be -1. So my final function should be just f of x, and my coefficient a is just -1, so I can just put -x, or I can put the 1 if I want to, x plus 3 squared times x minus 3 squared. And this function will produce that graph, okay? And that is the only function that will produce that graph.